Today our focus in geometry is going to begin a discussion of vectors and vector addition. For us, vectors will be a new and different idea. We've probably not seen vectors before, and definitely probably not vector addition. So when we're looking at these, this is a crossover subject with science, and in physics in particular. So first of all, a vector is a quantity that shows magnitude and direction. It's usually an arrow. So on this, first of all, you can see that there's a circle at one end and an arrow at the other. This arrow is a terminating point, and this is the initial point. Now normally when we draw an arrow on a line, it just shows us that it goes on and on forever. This arrow is really just showing us direction. That's what this part is kind of talking about as far as direction. Now the other big idea in this is that this is kind of a vector, if you want to think about it like a spinner on a spinning game that you would play, like on Twister when you would turn the dial to figure out where your hands or feet were going to go. This does not change length. It's fixed. So it'll typically have some kind of angle that's typically described with it, but this length is fixed and the direction shows you exactly which way it's going. So the magnitude tells you how big the actual line is, and that goes from the circle at this end to the arrow at the other. And then it also shows, the direction that's traveling in. Now when you see a vector, normally when we describe a line we usually have a full arrow here. You'll notice this one's only half. That's to signify that it's a vector. So part of this discussion is going to be how can we go to be able to calculate how long this is, or what it means to us as far as, its placement on a grid. So let's take a look at maybe this first one. Hang on, I just want to move it to the top of the page here. Okay, describe vector OL as an ordered pair. In other words, they want to know what this point is right there. So to figure out that exact point, I know I'd have to go over some positive amount of x and down some negative number of y. So I know whatever I get, this point here is going to have to look like this. Now the big thing for us to remember is that these brackets, typically if we're talking about something that's a vector, you're going to see something that looks a little more square, almost like greater than and less than signs that are going to be at either end. So if I want to be able to talk about this particular spot, I'm going to drop a line here just so you can see what I'm talking about. But if I were to drop a line right here, you should be able to tell that that gives me some kind of a right angle. Oops. Might help if I had a pen there. Okay, there's my right angle. The angle in here is 50. And the hypotenuse here is 65. Whatever this side is going to be x, because that's how many spots we'd have to go out to x before we went down y. And this side would be y. Now, I'm going to pull that triangle off just so it's a little bit easier for us to look at. So if I were to look at that triangle, here's my 50 degrees. This is 65, and this is x and y. Now because this is the only angle they tell us is 50, it's definitely going to have to be our focus angle. And this across would be opposite, and this side right here would be adjacent, and this side right here is going to be my hypotenuse. Now you can already see that things like sine and cosine and tangent are going to start creeping their way into a problem like this. So first of all, if we have to find this xy, let's find x first. If x is adjacent, and the only other side I know anything about is the 65, adjacent hypotenuse would have to give me cosine. So if I go to do this, the cosine of 50 degrees is going to have to equal adjacent over hypotenuse, which is 65. So if I go back to my discussion before of putting this over 1, I can go through and cross multiply in one direction then the other. So in one direction I'm going to have x, the other one I'm going to have 65 times the cosine of 50. Remember, nearest tenth is all we need. So 65 times the cosine of 50 is going to give me 41.78, yada yada yada, keeps going. Now remember, I only want up to the nearest tenth, so 41.8. There's my x value. So I know in a minute when I put this together, my 41.8 is going to be out in the front. Now, to do the next one, if I want to find y is opposite, hypotenuse is 65, so that tells me I'm going to use sine. So sine of 50 equals opposite over hypotenuse. And again, I'm going to go through, cross multiply. So y equals the sine, or equals 65 times the sine of 50. So 65 times the sine of 50. Again, I only want to go one decimal place, so it's 49.79, yada, yada, yada. So we'll just do 49.8. Now that means this is going to have to be a negative. Because remember what we talked about. To get to this point right here, I'd have to go over a positive x and down some y. So this part right here is my ordered pair they're trying to describe. Okay, let's take a look at the next one. This one says using compass directions to describe the direction of each vector. Now first of all, if I look at all these, the north, south, east, and west makes me think of just a regular, compass direction. But you can kind of tell that it looks like these vectors have moved down from where they were to a new spot. So if I were looking at these, first of all, it's easy to look at the degrees. I have 25, 35, and 30. No problem getting that part. But you can tell on this one that this one has moved south from where it was. And it moves south from actually pointing east. So this is going to be south of east. Now on this one you can tell that it's moved east of north. So 35 degrees east of north. Then on this one has moved 30 degrees west of north. Now those are easy ones to kind of confuse, so keep those ideas in mind. Let's see maybe if we can get into one more here. Okay, on this one it says an airplane lands 40 kilometers west and 25 kilometers south from where it took off. So if this is a spot where it took off, I just want you to imagine I go out here, go to the west 40, and then I'm going to go south 25. Even though this isn't a very good triangle, you can kind of see where I'm going with this. Fix that corner so it actually looks like a triangle. Holy mackerel. It wants to know the resulting vector can be described by negative 40 and negative 25. Okay. Use the distance and magnitude to describe it in a second way. So they're saying that negative 40, negative 25 would be right here. And usually, remember, we would probably make those straight, those ones that look like the greater than and less than symbols on the end. Now to describe this, we kind of have to do two things. We have to figure out where x is, this degree here, and also they want us to figure out this side. I'm actually going to make it c, so I know what that is. Now, probably the easiest thing for us would be to find c, because I can actually probably use Pythagorean theorem to do that. I can do, 25 squared plus 40 squared equals c squared. So 25 squared would be 625. 40 squared would be 1600. So 625 plus 1600 is 2225. And to get just c, I would have to do the square root of that. Now when I do the square root of 2225, it's not a whole number. So let's round it to the nearest tenth. That's what we've been doing with sides. Sides have been to the nearest tenth, and angles have been to the nearest whole number. So if I did C here, that would be, it's 47.169, it keeps going. So let's just do 47.2. So that's how long this actually is. That's the magnitude. Now my job is to find the degree, because this is going to be one of those that kind of combines the first and the second problem we did here. So to find this x, let me draw the triangle first. Okay, hang on, we're almost there. Flip it. Oh, there we go. So this is 25. This is 40. No, this is angle x. And although I know this is 47.2, I'm going to focus on using the 25 and the 40 because I really want to use whole numbers as much as I can, just so I don't have any issues with numbers coming out maybe not exactly what we need. So if I look at this, this 25 would be opposite of x for my focus angle. 40 would be adjacent. So if I have opposite and adjacent, then I'm going to be talking about tangent. So the tangent of x equals opposite over adjacent. So to get the x off, or the tangent off of there, I would have to do the inverse tangent of 25 over 40. So the inverse tangent of 25 divided by 40. Now again, we want to go to the nearest whole number because it's an angle. So it's 32.0053, keeps going. So that means if we rounded it to 32 degrees, that would be the easiest way. Now, if I were to describe this, we're going to have to put all of this together. So because we know this is a plane, we could say that the plane flew 47.2 miles, or kilometers, at 32 degrees. And if I were going to look at this, I would say it's moved south from west. So that means it moved 32 degrees south of west. Okay, so and this part's going to be our answer. So quite a bit of work to go into that. Let's see if we can hit this vector addition quickly here. So with vector addition, this is really the way it works. So first of all, I have a vector that's 4, 3, so over 4 up 3 is the end point there. And I have C, which is over -1 up 2. They want us to write the sum. So this is kind of the cheater's method of it. I'm going to line up my vectors right above each other so that my x values match up and my y values match up. And really, it's a big addition problem. So 4 plus -1 is 3. 3 plus 2 is 5. So this vector is the resultant of what we want. So listen, that means I go over 3. So 1, 2, 3, and up 5. 1, 2, 3. And the only thing that we're going to do with this one, oops, that's a pathetic dot. I'm going to grab one of my lines. Let's see if I can find one that's got an arrow on the end. Okay. Oh, that's the biggest one ever. Sorry about that, guys. Now, really what this means, I just want you to realize, if I were to take this vector C and move it over, can you see how this would be a right triangle? And that makes it like the stuff we've been doing before. So remember, this resultant is just the hypotenuse of the triangle if we were to move this over here. But keep it simple with the resultant stuff.